It's night time, but for me, it's basically day, and that's thanks to this week's project. Today, we're going to be building a gigantic floodlight. It's going to be incredibly bright and incredibly powerful. Oh, and it's also going to be battery powered. So without further ado, let's get into the video. I haven't actually seen what I've purchased here. I bought it sight unseen off of AliExpress. The seller claims that it has a 100 watt maximum light output and a diffuse lighting. So, let's see what we got. I ordered just a panel, but after unboxing it, I've discovered my life is going to be way easier. I have a panel with an LED controller and an RF remote on it. So I basically don't have to do any work with this project. If the seller's claims are correct, that this is a 100 watt output, we're going to have a lot of difficulty keeping it cool. That means it's going to have 70 watts of wasted heat. Fortunately, I do have this heatsink, which is not quite the right size, but I think I should be able to use it. In order to secure this to the heatsink, I used a generous helping of this thermal glue, which I bought online, which should harden after I apply a large amount of pressure to the heatsink. With the panel secured, I moved on to working out how I was going to power it. And in order to do this, I built a custom battery. It's a 4S 2P battery, meaning it has 4 cells in series and 2 in parallel. The cells I'm using have a maximum discharge of 25 amps, so I can do 50 amps total. Fortunately, we won't be drawing quite that much power. And with a capacity of 74 watt hours, it should last us about half an hour. Now that I have a battery, I need some way of charging the battery. And in order to do that, I'm going to build a charging circuit out of some off-the-shelf components so you can follow along at home. In order to get power actually into the unit to charge things, we're going to be using one of these, which is called a USB-C trigger board. Basically, its job is to tell the USB-C what power you want. In this case, we want 20 volts, so I'm going to solder over the shunt for 20 volts. This way, it will ask for 20 volts when I plug it into something, and should give me 20 volts out of these two contacts, which I will be putting directly into one of these. Now, this is a 15 amp converter for 20 to 25 volts, down to 5 volts. Why am I using 5 volts as the main thing? Well, because I'm going to be using a USB charger to charge my battery, because they are the most efficient. The problem is, each charger can only draw 4 amps from the socket on its own, and I want 3 of them in parallel to give me a much faster charging speed. If I had 3 in parallel that just plugged into a normal socket, this would blow up the socket because I would be drawing 12 amps at 5 volts, and no sockets are designed for that. But by drawing 20 volts, we drastically reduce that power draw. Although this is not the most elegant charger anyone's ever created, it is fit for purpose. It can charge our battery in about an hour and a half from 0 to full. Now, the important thing here when connecting it to the battery is that you do it with the correct polarity. Otherwise, you can end up with something going wrong and short-circuiting it. So in order to do this, it's slightly counterintuitive, but you want to take the ground or negative from your charger and connect that to the negative terminal of the battery. We then want to take the positive and connect that to the positive terminal of the battery. Now that we have a battery that can charge itself nicely, and a nicely mounted LED panel, we need some way to connect them together. And while I could simply twist the wires together, that's not very good every time I turn it on or off. And as this panel is driving nearly 13 amps, a standard switch is going to have to be quite big to overcome it. Well, that's where these guys come in. They're called Mosfets, and they're basically a fancy piece of silicon which does the switching process for you. What is a Mosfet and how does it work? Well, this is a Mosfet. It's basically a fancy piece of silicon which allows you to amplify voltages, or in this case, be a really high power switch. So how does it work? Well, you connect your 12 volt or positive terminal of your battery to the positive terminal on your load. You then connect the negative terminal of your load to the drain of the MOSFET. You then connect the source of the MOSFET to 0 volts or ground. You then connect the gate of the MOSFET to your switch. And this way, when you turn your switch on and off, you can put a voltage between the gate and the source. So here we have 12 volts, we close our switch, and we're putting 12 volts between gate and source. So if the threshold voltage of this MOSFET is below 12 volts, say for example 5 volts, then this will allow electricity to flow from the drain to the source, like that. But if we cut off this connection and open our switch, that then cuts off the connection here and stops the electricity from flowing from drain to source. Yeah, okay, this is where things properly start going downhill. This project was supposed to be something easy that I just undertook in the meantime while I'm working on some larger projects. But here this went from a simple project to one of the hardest things I've ever done in my life. And that is all thanks to AliExpress sending me the most useless MOSFETs in the world. They didn't work. And me being me, I thought I was doing something wrong repeatedly over and over again. I could not work out why there was no resistance between drain and source every single time I did anything. And then it hit me. The AliExpress MOSFETs probably weren't working. So I switched them out for an Infron MOSFET, and it worked perfectly well for a couple of minutes and then overheated and burnt up because it wasn't rated for this power. It turns out buying MOSFETs off AliExpress was a bit of a blunder because they don't work. The only MOSFET that I have lying around in the correct specification is a depletion MOSFET, which is fine. The only problem with that means if my switch fails, it will automatically default to the on position rather than the off position. However, if my switch doesn't fail, it works fine. With that sorted, I was able to move on to putting things into the box. And in order to do this, I started off by gluing the USB-C port in position so that I was able to charge it. I then basically insulated the other components and crammed them into position, securing them with Gorilla Tape or duct tape, whatever you want to call it, so that they wouldn't wobble around. And that was great. In order to attach the front on, I used some screws so I could access it again. Unfortunately, these weren't the nicest looking screws, but they do the job and it's pretty well sealed. So it's basically done now. Let's test it. It's done. And so am I, apparently. Oh my god. Am I nearly dead? Yes. Do I now have a working light? Also, surprisingly, yes. This wouldn't have been a hard project, except for the fact that I bought components off AliExpress, namely that MOSFET, and that meant that basically this video went 4 hours longer than it should have, because where I should have just soldered up a circuit, I instead spent 4 hours using 10 different AliExpress MOSFETs, all of them not working, before giving up and going to use a BJT. I have switched off every light in my room, which is why I have now switched to infrared imaging. Let's see how bright this is. 3, 2, 1. Crikey, mate. Now I can talk. I'm going to point this at myself so you can see me. It's kind of blinding actually. But now you can see that this is actually quite bright, and I can switch to my main camera and tell you that this is a very bright light and we should go outside because it's blinding me. Yeah, it's pretty blooming bright. And yeah, still the brightest light I've ever had. Definitely would recommend building this. Way. It's very dispersed as well. Let me show you. Oh. All in all, this was a very fun project. It was a little bit shorter than most people are used to, and that's fine. I'm trying out slightly shorter and easier projects for people to try at home. And I think if this is the first project you want to try, it's definitely a good one, because it wasn't too difficult. The problem, of course, being getting high quality Mosfets. But if you buy something from Inferon, you will be absolutely fine. Just don't buy your Mosfets off AliExpress and your problem is solved. So, definitely recommend doing this. And if you do, send me a picture because I'd love to see what you can create.